So welcome back to another session on how Westpac Mark IV works. And this is part 3, where we're going to recap how the route setting process works and look at a little bit more of the push button interlocking. So far what's happened? Well, we've looked at how you set a route, and that's all about the signaler pressing and then releasing the entrance button and then pressing and releasing an exit button. The entrance and the exit define the route to be set, and if it is available, then the route can be set. And all of those are controlled by the push button interlocking, the PBI, and the S ring, which monitors the pressing and releasing of buttons. With the route chosen, we looked at the UZR, CUR, and LUR, the combination of relays which is used to set and lock the route if it's available. And now what we need to do is look at how the PBI is restored ready for the next route. And that will help us to remind ourselves of the sequence, because if the sequence doesn't all complete, then the PBI, the push button interlocking, will reset. So what's its normal state? Well, there are a number of relays to consider. The first is the FCR, which is the checking relay monitoring the front position of the buttons, confirming that none of the buttons have been depressed. There's the main entrance selected relay, the MER, which records once an entrance has been registered, and that was from a main class of button. And similarly, there's a shunt class of SER, the shunt entrance selected relay. We're moving on to the destination, and we have the destination checking relay, a relay that's checking that no destinations, exits have been registered within the system. And that's repeated in the DCPR, which remains up even when the destination has been selected until the timer expires within the PBI. And we have the DJR, the destination timing relay. This is the relay which resets the PBI if nothing happens for a period of time. And typically that's 7 to 10 seconds after either an entrance has been pressed or an exit has been pressed that the PBI will reset. And we also have the route finished indicating repeat relay, or the UFKPR, a relay which is picked up once the route has finished setting. So we can see the normal positions of these relays. FCR is up, MER and SER are normally down, the DCR, DCPR, DJR are all normally up, and the UFKPR is down. There is one relay we haven't talked about, and I'm not going to cover it in these series of talks, the ONPR, the overlap switch repeat relay. In some instances, you need to enable the signaler to select where the overlap will go, and so this relay can monitor that. So we saw the DCPR right at the beginning. DCPR requires the DCR, proving no destinations registered, up, and then both the MER and SER down to prove that no entrance has been registered. And in order for the reset of the PBI, it requires that the DJR has dropped and the FCR is energized, proving that no buttons are being pressed and held in. Not an uncommon fault on push-button panels is with the buttons, and either they can be stuck in or they can fail to register. And if buttons stuck in will lock up the PBI. With the DCPR energized, it will then stick up over its own contact until the DCR drops. So what about the DJR? Well, the DJR has quite a complicated circuit, and at different stages in the process, different paths are used. What you'll also notice is on the right, there are a number of resistor capacitor storage devices, which give it a long time delay to drop. So our initial state is that the OMPR is down, the DCR is up, MER and SER are both down, DCPR is up, and the UFKPR is down, and that causes the DJR to energize. And with the DJR energized, then we can also look at how the various capacitor resistor networks will also be charged up. The MER down will feed the middle capacitor resistor network. So although it is not in circuit at the moment, that resistor and capacitor will be fully charged. And with the DJR up, then the bottom one will also be fully charged to hold the DJR up should anything else change. So let's recap how it works. So selecting an entrance. When you select an entrance and press one of the buttons, the relevant FPR in that set operates, and the FCR in the PBI drops to indicate that a button has been pressed. And the action of pressing that button enables the relevant SR, the start relay in the entrance set, to be picked and to stick. And it sticks, having sent a feedback to the MER or SER if it was a shunt entrance in the PBI at the bottom of the screen. So now our MER is up within the PBI. We also have the entrances being stored within the entrance set using the UER latched relay. That records that where the entrance will be, so even when the route setting process is complete, the entrance will still be stored. So what happens in the DJR circuit? Well, now that the MER and SER have picked, we lose the path holding up the DJR at the top. However, we also lose the feed to the middle capacitor, and that middle capacitor then can hold up the DJR via the DCPR contacts in the circuit in the green shown. So pressing the entrance switches the path holding the DJR from the permanent feed top left to the capacitor feed from the middle capacitor, which means that the DJR is now timing. And if the signaler doesn't press any buttons within the next 7 to 10 seconds, then the PBI will be reset, assuming that the route was not required. So the exit. Well, with no exit selected, the DCR was energized. However, when you press a button in the relevant exit set, the FPR there operates, and that causes the DR to energize. And you'll notice that the DR sticks up over contacts fed from the PBI. And there is its stick path. So going back to our DJR, what happens now? Well, we've now selected an exit, so the DCR has dropped, meaning there is no feed to the bottom capacitor resistor to keep it charged. Not that that matters at this point. Also, the DCR dropping is going to drop the DCPR, and so we lose the feed from the middle capacitor resistor through the DCPR contacts to the DJR. So now what is going to hold up the DJR? Well, with the DCR down, and I've just realized that I have made a mistake on this drawing. So please imagine that in the left-hand contacts, the red line should go through the DCR back contact, and then the MER up contact and the UFKPR back contact to feed the DJR. So the bottom capacitor resistor is now holding the DJR up. We're waiting for the route now to set. So if you remember, the way we test if the route is valid is a feed going from the entrance set looking for a main or some shunt destination available relay in the exit set. And the negative feed to those relays comes from the PBI. If the exit is available, then the exit needs to be stored by latching the relevant route finish relay, the UFRs. And we now get our famous UZR, CUR, and LUR chain. The UZR in each set picks and remains up until the route has been set in the previous section of the route. So the first UZR would be down, the second and third would be up, and that would enable the first CUR coil to pick up. And once the LUR in that set has unlatched, then the next CUR will pick up, and so on. And we can see the LUR release line, also fed from the entrance set, working its way through the route. As each CUR picks, the LUR releases. So how do we know then when route setting is finished? Well, in each of the track sets, the CUR becomes bridged out with the CUPR up and the LUR down. The feed from the entrance set is over a relay with a resistor around the coil. Because of the resistor around the coil, most of the current flows through that resistor in order to pick up the CURs. However, when all of the CURs are bridged out, all of the voltage will appear across the FKR, and at that point it will energize. So the resistor is actually quite a low resistance relative to the relay coils of both the FKR and the latched relays in the circuit. And that results in a voltage of approximately 42 volts across each of the CUR pickup coils. And that is more than enough to actually operate the relay. Which means, of course, that the residual 8 volts is across the FKR coil and the resistor, which means that that FKR will not operate until all of the other coils are being bridged out. The FKR feeds back on a line to the PBI and operates the UFKPR. Any of the FKRs operating will operate the UFKPR. So that cuts the feed to the DJR. And after a very short period of time, the DJR drops and the PBI resets. So the DJR dropping cuts the stick path to the SR relays because the MER and SER have both dropped. It also cuts the stick path to the DR relays and that enables the DCR to pick. The MDAR and SDAR also drop, and the feeds to the CUR pickup and LUR release lines are cut at both the entrance and exit. And with all those relays resetting, that enables the DCPR that we started with to repick, enabling the DJR to repick if everything is normal. So the DJR provides a period of time. There's only so much time after the signal has selected the entrance for the exit to be selected. And similarly for this, once the signaler has selected the exit, the route has to set within the time the DJR takes to drop. And if the DJR drops at any point during the route setting process, then that route set is cancelled and the system will restore. Now, with a limited amount of time, it makes fault finding quite difficult. So one of the features provided in the push-button interlocking is a key switch where you can keep the feed to the DJR maintained whilst you undertake fault finding throughout the interlocking. In addition, on the push-button interlocking, there are some indication lights which assist in fault finding. One can see when the various lines are energized. And there is also an ability to test some of the loops. So that is our push-button interlocking and route setting completed. Now we need to prove the route and clear the signal. But we'll leave that for next time.